Hi everyone, welcome to goclasses. So in the last lecture, we were discussing functional dependency. We have already seen the concept of functional dependency and all the functional dependency rules we have seen. Now, in this lecture, we will do some practice of finding candidate keys from the functional dependency. Okay, if a set of functional dependency is given to you for a relation, then how can we find candidate keys of that relation from the functional dependency? Okay, so this is our chapter for today. Now, we have already seen the definition of candidate keys in terms of functional dependency. We have also seen the definition of super key in terms of functional dependency. So tell me the answer for this question. What will be the answer for this question? In a relation R, if x plus is entire R, means this x can determine the entire R. All the attributes this x can determine. Then what is x? Then this x is a super key. You cannot say it is candidate key. You cannot say candidate key. You cannot say primary key. Okay, and this is not foreign key. This is basically super key. So your answer will be super key. Very simple. Now, tell me the answer for this question. In a relation R, if x plus is entire R, means x can determine all the attributes. And for every y, which is proper subset of x, y plus is not R, means if y is proper subset of x, then y cannot determine all the attributes. So what is x now? Now what is x? Now here answer will be candidate key, also super key, because every candidate key is also super key. Yes or no? So here the answer will be option A, option B. Is this clear? Okay, so here you can see in this situation I can say that this x will be a candidate key. This x will be a candidate key. And remember, every candidate key, that is a super key. Every candidate key is also super key. Okay, so your answer will be option A, option B. Is this clear? Please tell me. Let me know. So these are the definitions. So remember, these are the definitions that we have seen. If you have a relation R, let's assume you have a relation R, and in this relation R, let's assume that x is a set of attributes. What is x? X is, let's assume, some set of attributes. Okay. Now in this situation, when can I say x is super key? When can I say that x is a super key? When can I say that x will be a super key? X will be a super key if and only if x can determine every attribute. Yes or no? X can determine the entire R, means x can determine all the attributes. Okay. The same statement I can also write like this. The same statement I can say that x is a super key. When can I say that x is super key? X is super key if and only if x plus contains all the attributes. Okay, x plus is your R, means x plus contains all the attributes. Very simple. This is the definition of super key. Okay, so this is if and only if. Very simple. Now tell me the definition of candidate key. What is the definition of candidate key? When can I say that x is a candidate key? When can I say that x is a candidate key? Tell me. X is a candidate key if and only if. What should happen? Two things must happen. Two things must happen. The first thing, that x plus must be R. Okay. The first thing means x can determine all the attributes. Okay. X should determine all the attributes. And what is the second thing? The second thing is that no proper subset of x is a super key. Yes or no? I can simply say no proper subset of x. No proper subset of x can determine all attributes. Can determine all attributes. Can determine all attributes. Okay, is this clear? Tell me. Very simple, right? Yes or no? So you can see, when can I say x is candidate key? X is candidate key if and only if x can determine all the attributes, and no proper subset of x can determine all the attributes. Okay, so you can see this is your definition of super key. Here basically you are saying that super key, x is a super key, and here you are saying that x is minimal. Here you are saying that x is minimal. Yes or no? Here you are saying that x is minimal. Okay, is this clear? And what is minimal super key? If I add these two things, tell me, what is a minimal super key? If I add these two things, what I will get? I will get a candidate key. Yes or no? I will get a candidate key. Very simple. Okay, so these are the definitions we have already seen. Now we have done the revision also. Now let's move on. So all the definitions we have already seen. The definition of super key we have seen. K is a super key for relation R. When can I say K is a super key for relation R? If K can determine all the attributes. Yes or no? K can functionally determine all the attributes. This is the definition of super key. Now, when can I say that this K is candidate key? Key means candidate key. I told you that key, this means candidate key. This means candidate key. Okay, by default, whenever you see this word key, this means candidate key. Key means candidate key. By default, key means candidate key. So tell me, when can I say this K is candidate key for R? This K is candidate key if K is super key, but no proper subset of K is a super key. Okay, means no proper subset of K can determine all the attributes. So this is what we have seen. Okay, now let's move on now. Now let's solve this question. In this question, this relation is given to you. These functional dependencies are given to you. Okay, so on this schema, on this relation, these functional dependencies we have defined. Now the question is asking, answer the following questions. Some questions are there. Let's answer one by one. Tell me what the closure of this B? What is the closure of this B? Tell me what the closure of this set means. This set is given to you, and the question is asking what the closure of this set. So tell me what will be the closure of this set? Which attributes B can determine? Remember, closure of B, that means all the attributes which B can determine. Yes or no? Basically, we want those attributes which B can determine. Which B can determine. Yes or no? We want those attributes which B can determine. This is the definition of closure of B. Okay, so we want all those attributes which B can determine. So tell me which attributes B can determine. So you can see that B can determine what? I can say B can determine B. Yes or no? I can say that in this B plus, what you will do? You will put B. So B can determine B. Why? What is the reason? B can determine B. Why? What is the reason? B can determine B because of reflexivity. Because of reflexivity, you can see that B can determine B because of reflexivity. Okay, this is your reflexivity law. Or I can say this is your trivial functional dependency. Or I can say this is your trivial functional dependency. So very simple. So B can determine B. What else B can determine? You can see B can determine G also. So this G will also come. Now these two things, these two people, what they can bring? See, B can determine B comma G. Now these two people, what they can determine? These two people, what they can determine? You can notice this G. This G can determine A. You can notice this G can determine A. So you got A also. We got A also. Now these three people, what they can determine? We have these three people, B, G, A. What they can determine? Tell me. So you can see this A itself. This A can determine B, G, C. This A can determine B, G, C. We already have B, G. So we got C also. We got C also. Okay. Yes or no? So now these four people, what they can determine? These four people, what they can determine? So you can see that this BC, this can determine GH. Yes or no? Notice this BC. Look at this B and this C. This BC, this can determine GH. You already have G, so you can put H. What else we can get? Tell me, what else we can get? Let me know. You can see C can determine I. Yes or no? You can easily see C can determine I also. So we got I also. Okay, this C can determine I. Okay, so we got I also. So tell me, did we get all the attributes? Tell me. So B can determine the entire R, can I say? Can I say B can determine the entire R? Okay, if B can determine the entire R, so what is B? So what is B? B is a super key. B is a super key. Yes or no? B can determine the entire R, so B is a super key. Now you tell me, is this minimal? This B is a super key. Is this minimal? Of course, this is single attribute. This is single attribute. Of course, this is minimal. This is only one attribute. Okay, you cannot create a proper subset. Yes or no? So very simple. This is single attribute, and this attribute is single attribute, and this is super key. So this is candidate key also. So you can see that this B is a candidate key. Remember, I can say this B, this is super key and minimal. This is super key and minimal. So I can say that this B is a candidate key. Okay, yes or no? We got one candidate key. Is this clear? So our part 1 is done. Okay, we have done this part 1. Now let's see the part 2. Let's see part 2, that is G plus. Tell me what the closure of G. Let me know. Now the question is asking what the closure of G. What G can bring. Tell me what G can determine. Let me know what G can determine. See, remember what the definition of closure? When you find the closure of G, this means we want those attributes which G can determine. Those attributes which G can determine. So tell me what G can determine. Let me know. This G plus what that will be. What G can determine. So here you can see G can determine A. See, G can determine G. G can determine A. Now these two people, what they can determine? These two people, you can see this A can determine BC. Okay, this A can determine BC. Now you can stop here. Why? Why? Remember, you got B. You got B. But B can determine everyone. Yes or no? Notice B can determine everyone. Agree or not? See what you got. You got B. Now this B is so powerful. This B is so powerful. It can determine everyone. This B can bring everyone. Yes or no? Agree with me? So once you got B, once you got this B, now this B can bring everyone. Because of this B, you can get everyone. Because B is super key. B can determine everything. Okay, yes or no? B can determine the entire relation. So because of this B, what I can say, now everything will come. Okay, now you don't have to check. You can just simply say that everything will come. So G, A, B, C. Okay, now you will also get H, I. So now tell me, can I say that G can determine B? And so you can notice G can determine B. Okay, and this B can determine everything. So transitively G can determine everything. Agree? Yes or no? G can determine B. B can determine everything. So transitively, this G can determine the everything. So tell me, G can determine R. So what that means? G can determine R. What that means? That means G is a super key. G is a super key. And is it minimal? Is it minimal? Is it minimal? So remember this G, this is a super key and minimal. This is minimal also because this is single attribute. So that is the reason I can say this G, this is a candidate key. Yes or no? This G is also a candidate key. So we got this G is also candidate key. Very simple. Is this clear? Did you understand? Please tell me. Okay, very simple, right? Now tell me one more thing. Tell me one more thing, interesting thing. See, if anyone, B is already a super key, you got B is a super key and G is a super key. Okay, B is a super key, G is a super key. These two people are super key. These two people are super key. Tell me, if some person, okay, if someone, let's assume, if someone can determine B, then can I say that person also will be super key? Tell me, if this person can determine B, if this person can determine B, then from here, can I say that this person, what is this person? Can I say this person will be a super key? Yes or no? Agree? Because this person can determine B and this B itself is super key. Okay, this B itself can determine everything. So this person can determine everything. So this person is super key. Yes or no? Very simple. Agree with me? Okay. So now tell me, you already know B is super key, G is super key. So tell me, can I say A is also super key? Yes or no? Can I say A is also super key? Because you can see A can determine B. Okay, A can determine B. And remember this B is a super key. So that is the reason I can say A is also super key. And because this is minimal, this A is minimal also. Okay, this is super key also and this is minimal also. So that is the reason what I can say. I can say that this A, this is a candidate key. You got another candidate key. Is this clear? We got another candidate key. This another candidate key we got. Okay, so this A, this is also a candidate key. Understood? So very simple idea. So what rule I can say? Can I say this rule? Tell me, if you already know that X is a super key. Okay, if you already know X is super key or candidate key, every candidate key is super key. Yes or no? If you already know that X is super key, okay, and let's assume Y determines X, then what I can say about Y? Then what I can say about Y? Then Y will be a super key. Yes or no? Then Y will be a super key. You cannot say candidate key. Okay, Y will be a super key. We cannot say that Y will be a candidate key. Remember, yes or no? Okay, we cannot say that Y is a candidate key. We cannot say that Y is a candidate key. Okay, but we can say that it is super key. And if it is minimal, okay, I can say if Y is minimal, then I can say that it is candidate key. Yes or no? if y is minimal, if y is minimal, then y will be super key. Okay, if y is minimal, then I can say it will be candidate key. Okay, if y is minimal also, then y will be candidate key. So this is the rule. Now let's move on. Now let's see the next question. So we have done this, we have done this. Now tell me, what about super keys? The question is asking for super keys. Let's find out super keys. But before that, let's find what are the candidate keys. Let's do this. What are the candidate keys? So tell me, what are the candidate keys so far? So far we got that B is a candidate key. Yes or no? So let's find out what are the candidate keys. We got that B is a candidate key. We got G is a candidate key. A is a candidate key. 3 candidate keys we already got. Okay, we already got these candidate keys. Yes or no? Now, is there anything else? Is there anything else? First you tell me one thing. Remember, these are already candidate keys. Okay, so can you create a candidate key which contains these? Tell me, can you create a candidate key which contains these? No, no, yes or no? Because candidate key is minimal. Yes or no? Because candidate key is minimal. So very simple point. This point you remember that if you know, if X is candidate key, if X is candidate key, then X, Y, for all Y, yes or no? Then X, Y. Okay, then X, Y is never a candidate key. Yes or no? Then X, Y is never candidate key. Where what is Y? Where Y is non-empty. Where Y is a non-empty. Is this clear? Non-empty set of attributes. Please tell me, is this understood? So you can see, if you know that X is already candidate key, then it's a superset, it's proper superset. That is never a candidate key. Its proper superset is never a candidate key. Yes or no? Very simple point. So tell me what I need to check. What else I need to check? I cannot consider these. I cannot consider these, remember, because these are already candidate keys. So they cannot be part of any bigger candidate key. These are already candidate key. So they cannot be part of any bigger candidate key. Okay, this is what I can say. So remember, this is what I can say, that if X is a candidate key, then it cannot be part of any bigger candidate key. This is what I can say. If X is a candidate key, then X cannot be part of any bigger candidate key. Part of any bigger candidate key. Yes or no? Is this clear? Please tell me. If X is already a candidate key, then it is minimal. Okay, yes or no? Then it is minimal. So if X is a candidate key, then it cannot be a part of any bigger candidate key. Okay, you using X, now you cannot create a bigger candidate key. Bigger candidate key you cannot create. Okay, because X is already a candidate key and candidate key is minimal. Okay, so you cannot create a bigger candidate key. Very simple. So now tell me, what else I need to check? What else I will check? So B, G, A, these I cannot consider. This B is gone, this G is gone, A is gone. Now the remaining attributes I will check. I will check one by one what they can bring. For example, what is C plus? Okay, now what I will do, notice, I will do this C plus. What is C plus? Tell me. What C can bring? Let me know what C can bring. C can bring C. C can bring I also. C can bring I also. What else you can bring? These two people, what they can bring? These two people, they cannot bring anything else. Yes or no? That's it. Tell me. So can I say C is not a candidate key, right? Yes or no? So I can say C is not a candidate key. I can say this C is not a candidate key. Okay. What else? This C is not a super key also. This C is not a super key also, because you cannot determine all the attributes. C cannot determine all the attributes. This is not a super key also. Now tell me, what is remaining? H. What is H plus? What is H plus? What H can bring? H can bring H. That's it. H can only bring H. Okay. What I can bring? Tell me what I can bring. What this I can bring? I can only bring I. Okay. Now tell me what I will check now. So single people, these are not candidate key. These single people, these these are not candidate key. Now I will check these double people. Okay. Remember all the single people I have checked. All the single people, like this B is a candidate key, G is a candidate key. So single people are done. Agree with me? C is done, H is done, I is done, single people are done. Now I will check combination of two, double people. Now I will check double people. Okay, combination of two. Now tell me, when I create combination of two, when I check combination of two, can I include one of them? When I check combination of two attributes, now I will check combination of two attributes. So tell me, can I include one of them? I cannot include. Yes or no? Because these are already candidate key. These are candidate keys. So they cannot be part of any bigger candidate key. Okay, so if I want to check double people, two attribute combination I want to check, then how many combinations I need to check? Tell me how many combinations? I need to check these combinations, CI, I need to check CH, and I need to check HI. Do you agree? Yes or no? Please tell me. I need to check CI, CH, HI. These combinations I need to check. Now tell me. Can you check? Is this candidate key? You can check what is the plus. What is the closure of CI? That also will be CI. What is the closure of CH? That will be CH. Yes or no? That will be CH. What is the combination of HI? That will be HI. Again, these are not candidate keys. Yes or no? All these people, these are not a super key. These are not candidate keys. Okay. Now what I will do? Can I stop here? Can I stop here? Please tell me. Can I stop here? No. Now I need to check triple people. The combination of three attributes. Now I need to check the combination of three attributes. Okay, but I cannot include these. These three people I cannot include. So tell me, how many combination of three attributes are remaining? How many combination of three attributes are remaining? Only this combination of three attribute is remaining, CHI. Yes or no? CHI. Now tell me, what is the closure of CHI? That is CHI. Again you can notice this CHI. Again you can notice this CHI. This is not a super key. Yes or no? Again this CHI. This is not super key. Okay, this is not super key. This is not candidate key. Yes, correct. Okay, so that's it. Is this clear? So now I can stop. Do you agree with me? Do you agree with me? Now I can stop and I can say that what are the candidate keys? So finally, what are the candidate keys? Please tell me. Finally, what is the answer for this question? What are the candidate keys? What is the answer for this question? Please tell me. What is the answer for this question? For this question, the answer is, what are the candidate keys? Okay, the candidate keys are these. This is a candidate key. This is a candidate key and this is a candidate key. Nothing else is a candidate key. Yes or no? These three people are candidate keys. No other candidate key. No other candidate key is there. Okay, these are the candidate keys and no other candidate key. Yes or no? Only these three candidate keys are there. Now, once you have all the candidate keys, then you can find the super keys very easily. Yes or no? Once you have all the candidate keys, then how will you find all the super keys? Please tell me. You have all the candidate keys. Remember, this is your relation. In this relation, you have A, B, C, G, H, I. A, B, C, G, H, I. Okay. And what are the candidate keys you got? What are the candidate keys? So here you got these candidate keys. Okay. This is a candidate key. This is a candidate key. This is a candidate key. You have all the candidate keys. Now tell me how to find the super keys. Tell me how to find the super keys. Now I want to find the super keys. I want super keys. Super keys will be superset of these. Yes or no? Okay, super key will be basically, I can say superset of these. Yes or no? I can say super key will be basically any combination of attributes containing at least one of them. Okay, I can say any combination of attribute. This will be any combination of attribute containing at least one of them. Containing at least one of them. Containing at least one of candidate keys. Yes or no? Is this clear? Please tell me. Is this clear? So remember, what is a super key? Super key will be any combination of attributes. Any combination of attributes containing at least one of the super key, containing at least one of the candidate keys. Containing at least one of the candidate keys. Okay, containing at least one of them. Very simple. So its superset, that is also super key. Its superset, that is also super key. Its superset, that is also super key. Yes or no? Agree? Now finally we need to find how many supersets we can create. So how to do that? Now you can apply the inclusion exclusion principle. See what I will do. Okay, just find out how many supersets of A are there. Okay, how many supersets of B are there? How many supersets of G are there? Something like this. Okay, just create the Venn diagram, apply the inclusion exclusion principle. So tell me how many super keys will be there. I want number of super keys. I want number of super keys. So how to do that? Very simple. You find how many supersets of A are there. Okay. How many supersets of A are there? Let me denote like this. Let me denote like this. What this means? What this means when I denote like this? When I denote like this, okay, assume this means, assume this means, okay, I am saying assume this means set of super keys containing X. Is this clear? Set of super keys containing X. Or I can say number of super keys containing X. Is this clear? Let me know. Okay, so anyway, this is set of super keys containing X. Super keys containing X. Containing X. So tell me, now tell me, how many super keys contain X? Let me know. How many super keys contain X? These are the attributes. These are the attributes. So tell me, how many super keys contain X? Means how many super keys contain A? Any superset? Yes or no? You can create any superset. Okay, so the remaining attributes, they have two choices. Either you can take it or don't take it, 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 take it or don't take it. Yes or no? So that will be 2 power 5. Okay, so is this clear? So remember, your answer will be what? So please understand, how many super keys will be there? That will be how many these are there. Okay, means how many these are there plus how many these are there plus how many these are there plus minus what I will do? Minus what I will do? Tell me. Minus what I will do? Tell me minus what I will do? How many these are there where you have A also, B also? Yes or no? Minus how many these are there where you have A also, C also? Minus how many these are there where you have A also, or I can say B also, C also? Okay. And finally, plus how many these are there where you have A, B, C, all of them? A, B, G. Sorry, that is G. A, B, G. Okay. So instead of C, this should be G. Okay. So this is your G. Is this understood? Please tell me. Is this understood? This is inclusion exclusion principle. This is your inclusion exclusion principle. See what we are doing, nothing else. These are the candidate keys. Remember, what is a super key? Super key is any combination of attributes containing at least one of them. Okay, super key is basically any combination of attributes containing at least one of them. Containing at least one of them. Okay, yes or no? Basically, this is your super key. Super key means any combination of attributes containing at least one of them, means their superset. Okay, their superset. Okay, its superset is super key. Its superset is super key. Its superset is super key. Okay. Now what we can do? Very simple. So number of super key will be how many supersets of A are there plus how many supersets of B are there plus how many supersets of G are there minus how many supersets of A comma B are there, how many supersets of BC are there, and how many supersets of AG are there plus how many supersets of ABG are there. Yes or no? So now tell me, how many supersets of A are there? Let me know. So your number of super keys, that will be number of super keys. What that will be? So tell me, how many supersets of A are there? How many supersets of A are there? So that will be your 2 power 5. Okay, these many supersets of A are there. Okay, and the same value you will get if I ask you how many supersets of B are there. The same value you will get. And if I ask you how many supersets of G are there, how many supersets of G are there? Same value you will get. Yes or no? 32, 32, 32. So same value you will get. Okay. So these you can add. I can say you can add these 2 power 5 plus 2 power 5 plus 2 power 5 minus what I will do. Tell me how many supersets of AB are there? How many supersets of AB are there? How many supersets of AB? You can see that will be 2 power 4. That will be 2 power 4. So that will be your 16. And the same value you will get if I ask you how many supersets of AG are there. That also will be 2 power 4. How many supersets of BG are there? That also will be 2 power 4. Okay, so these are your 2 power minus 2 power 4 minus 2 power 4 minus 2 power 4. Plus how many supersets of ABG? Plus how many supersets of ABG? ABG. How many supersets of ABG? that is your 2 power 3. So plus 2 power 3. This will be your final answer. Understood? Understood? Please tell me. Can you calculate? Can anyone calculate and tell me what is this final value? This final value, what is that? That will be 56. So 56 super keys will be there. Understood? Let me know. Okay, so this is the interesting question, right? See, in the question, let's assume in the GATE exam, they directly ask you super keys. They directly ask you super keys. Then what is the best way? Let's assume in the GATE exam, they directly ask you super keys. Remember, if they directly ask you super keys, then tell me, what will be the best way? If they directly ask you this, what is the best way? Let me know. The best way is find candidate keys and then apply this method. Okay, is this clear? The best way, what is that? That is your, first you find candidate keys. Okay, just find candidate keys and apply this inclusion exclusion principle. Okay, just apply this inclusion exclusion principle. Okay, is this clear? Okay, so very simple. So find candidate keys and apply the inclusion exclusion principle. This is the best way to solve this type of question if they ask you super keys. Is this understood? Please tell me. All the 4 parts of this question, did you understand? All the 4 parts, let me know. Now let's move on. Tell me the answer for this question. In a relation R, A, B, C, D, E, these are the attributes. Given set of functional dependencies S, this is your set of functional dependency. If this attribute E does not appear on the RHS of any FD in S, this E does not appear on RHS of any FD in S. Okay, any FD in S. Now tell me. Now tell me. So who can determine E? Only E can determine E. Yes or no? Only E can determine E. So remember, if E is not on RHS of any FD, then who can determine E? Then who can determine E? Only E. Only E can determine E. Yes or no? Only E can bring E. No one else can bring E. No one else can bring E. Yes or no? So only E can bring E. So tell me, so can I say, in this type of situation, can I say every candidate key will contain E? Okay, remember, candidate key should derive everything. Remember, candidate key should derive everything. Okay, yes or no? Candidate key should derive everything. Okay, this should derive everything, A, B, C, D, E. But who can derive E? Remember, candidate key can derive everything. See, candidate key should derive everything. But who can derive E? But who can derive E? But who can derive E? Only E can derive E. So I can say that candidate key contains E. So can I say that every candidate key contains E? Every candidate key contains E. Yes or no? Every candidate key will contain E. Is this clear? Please tell me. Is this understood? Let me know. Because candidate key should derive everything, all the attributes. Candidate key will derive every attribute. So every candidate key contains E. The same thing can I say for super key? The same thing can I say for super key? Super key must derive everything. Okay, so again, every super key also contains E. Okay, is this clear? So every super key contains E and every candidate key contains E. And every candidate key contains E. Okay, if this type of situation happens, what the situation? The situation is this, that this attribute does not appear on the RHS of any FD in S. Okay, this is your set of functional dependency. In this set of functional dependency, this E does not appear on the RHS of any FD. So only E can determine E. So I can say, what I can say E must appear. E must be a part of every candidate key. Yes or no? E must be a part of every candidate key. So let's move on now. Tell me the answer for this question. 3 questions are given to you. All these questions are standard questions from standard university. So let's see the first question. Tell me the answer for the first question. Let's solve it. The first question is asking, find all the candidate keys. We need to find the candidate keys for the relation A, B, C, D, E. The functional dependencies are given to you. The functional dependency that exist in the relation R, those are given to you. Okay, now we need to find what are the candidate keys. So these are the functional dependencies. The relation is given to you, that is A, B, C, D, E. These are the attributes. Okay, now functional dependencies are also given to you. These are A determining B. A can determine B. BC can determine E. Okay, BC can determine E. Next, ED can determine A. ED can determine A. Okay, we need to find what are the candidate keys. What are the candidate keys? We need to find the candidate keys. So, first of all, you tell me, is there any attribute which does not appear on the RHS? Is there any attribute? Okay, see, this is the step number one. This is the step number one. First, find those attributes which do not appear on RHS. First, you find those attributes. First, you find those attributes which do not appear on RHS of any FD. Yes or no? Which do not appear on RHS of any FD. On RHS of any FD. Any functional dependency. Okay. Remember, such attribute will be part of every candidate key. Such attributes will be part of every candidate key. Yes or no? Will be part of every candidate key. Every candidate key. Is this clear? Such attribute will be part of every candidate key. Okay. So now you tell me, is there any attribute which does not appear on the RHS? Which do not appear on the RHS? Okay, find these attributes. So tell me, is there any attribute which does not appear on the RHS? Yes, CD do not appear, right? Yes or no? Here you can see that these attributes CD, they do not appear on the RHS. C does not appear, D does not appear. So we got that CD must be part of every candidate key. Yes or no? CD must be part of every candidate key. So let's start with CD, every candidate key. Okay, so remember, this must be part of every candidate key. So let's start with CD. Are they powerful to bring everything? Are they powerful? So start with CD, because CD will be part of every candidate key. Are they powerful to bring everything? CD can bring C, CD can bring D. Okay, nothing else. Yes or no? CD cannot bring anything else. So CD can bring only this. Okay, so we need something now. We need something more. Remember, candidate key is minimal. So now you build up your game. See, okay, note that candidate key is minimal. Note that candidate key is minimal, right? Okay, minimal. So now what you do, now you slowly grow. Systematic way. Okay, remember, candidate key is minimal. So what you do? So now you grow the size. Okay, one by one, systematic way. Yes or no? So now grow the size. Yes or no? Now grow the size in a systematic way. Okay, so that you don't make any mistake. In a systematic way, covering everything, covering every possibility. Okay, covering every possibility. You should check all the possibilities, checking all possibilities. Okay, checking everything, checking all possibilities. Checking all possibilities. Is this clear? Because candidate key is minimal. Okay, candidate key is minimal. So now what you do? CD, they must be part of every candidate key. This CD must be part of every candidate key, but they are not enough. CD is not enough. Yes or no? So now you include something more. Okay, step by step, one by one. So now what you do? Now you include one attribute. Which attribute you will include? Which attribute you will include? Tell me. Now you will include one attribute. Let's check. Can I include A? Will it work? Let's check. Okay, go systematic way. Always go in a systematic way. Let's include A. If you include A, will it work? Will it work? Now what you can bring? You can bring A, C, D. Okay, A can bring B. Yes or no? Basically, now you find what these people can bring. These three people, what they can bring, what they can determine. These three people, they can determine A, C, D. Now A can determine B. A can also determine B. Okay, now BC can determine E. Yes or no? These two people, BC can determine E. So these two people, they can determine E. So finally you got E also. So you got A, B, C, D, E. Yes or no? You got everything. That is same as R. So definitely this is a candidate key. Yes or no? So can I say this is a candidate key? Agree with me? Please tell me. So this is a candidate key. So remember, this ACD is a candidate key. This is a candidate key. You got one candidate key you got. Okay. Now what I will do? Now I will include in this CD. Now I will include B. Okay. Now I will include B also in this CD. Now I will include B also. Agree with me? Okay. So now what I will do? So remember, CD must be part of every candidate key. This CD must be part of every candidate key. Of every candidate key. Something interesting you notice here. Something interesting. See, ACD you got that this is a candidate key, right? This is already a candidate key. ACD is already a candidate key. Okay. This is already a candidate key. Now you notice. Can you notice ED can bring A? Can you notice ED can bring A? See, this A you can bring from ED also. So what I'm suggesting that instead of this A, if you put E, now ED can bring A. So this ECD will bring ACD. Do you agree with me? Please tell me, did you understand? See what I'm saying. I am saying that ED, okay, ED can bring A. This A you can bring from ED. So what I can do, let's check this ECD. Now you can note this ED can bring A. So finally I can say ECD will give you ACD. And this itself is what? This itself is candidate key. And so that is the reason what I can say, this is minimal or not? This is minimal also. Okay, so this is minimal and super key. This is minimal and super key. Yes or no? This is minimal and super key. So this is candidate key. Did you understand? This is minimal. This is minimal. Okay, because CD must be part of every candidate key. This is CD must be part of every candidate key. But CD is not enough. So one more attribute you are including. So ECD, that is also candidate key. This idea, did you understand? Okay, this idea, did you understand? So I can say this ECD, that is also a candidate key. Okay, is this clear? This ECD is also candidate key. Now something interesting. What is that? You know ECD is a candidate key. You already know that ECD, that is a candidate key that you already know. Okay. Can you notice BC can bring E? Can you notice that BC can bring E? BC, this BC can bring E. Yes or no? Can you notice? So what I'm suggesting that with this CD, you include B. Okay, what you do? Just check it. With this CD, you check this B. Now, this BC can bring E. Okay, this BC can bring E. So you got ECD. And that ECD itself is candidate key. That is also candidate key. So what this will be? So this will be super key, right? So this will be super key, and this is minimal. And this is minimal. This is super key and this is minimal. So I can say this is candidate key. So what you got? You got BCD is also candidate key. Okay, BCD is also candidate key. So far, how many candidate keys we got? So far, remember CD is not enough. CD must be part of every candidate key, but CD is not enough. Okay, but CD is not enough. I can say CD is not enough. Is this clear? CD is not enough. So tell me, now you will add one attribute. Okay, so we add one attribute. So what we do? We add one attribute. So what we do? We add one attribute with CD. With CD and check. This is what we do. Okay. Now you can notice this ACD will also work. This ACD will also work. This BCD is also working. ECD is also working. Okay. All of them are working. Okay. All of them are working. Yes or no? All of them are working. Now you tell me, do you need to check for the combination of 4 attributes? Do you need to check? Please tell me. See, ACD is also working. BCD is also working. ECD is also working. Now, do you need to check combination of 4 attributes? You don't need to check. Why? You don't need to check. You don't need to check combination of 4 attributes. Why? Okay, because those will be superset of these. Yes or no? Yes or no? If you check combination of 4 attributes, now remember, now if you do this, now if you check combination of 4 attributes, okay, now if you do this CD and you take 2 more attributes, then what will happen? That will be superset of this. Yes or no? CD. Now if you bring 2 more attributes from here, if you bring 2 more attributes, then that will become superset of candidate key. Yes or no? So can I say, if you bring here, if you bring from A, I can say ABE. From ABE, if you bring 2 more attributes, then that will be proper superset of candidate key. Yes or no? That is going to be proper superset of candidate key. That will be proper superset of candidate key. So this you don't have to check. So this can never be candidate key. This can never be candidate key. That's it. This is your answer. So these are the candidate keys. Finally, remember, finally your answer for this. What are the candidate keys? Tell me. What are the candidate keys? For this question, the candidate keys are ACD. This is a candidate key. BCD. This is a candidate key. And ECD. This is a candidate key. So 3 candidate keys are there. Is this clear? So 3 candidate keys. Understood? Let me know. Is this question clear? So this is how you can solve this question. Now let's move on. So this question we have done. Now let's see the second question. Tell me the answer for this. These attributes you have A, B, C, D, E, F. Following functional dependencies are given to you. These are the functional dependency. We need to find all the candidate keys. Tell me, is there any attribute which does not appear on the RHS? Is there any attribute which does not appear on the RHS? Let me know. Let me know. Is there any attribute which does not appear on the RHS? Do we have such attribute? So you can see these are the attributes A, B, C, D, E, F. Okay, so you can see A appears, A, B, C appears, A, B, C, D, E, F. All of them are appearing. Okay, so what is your starting point? What should be your starting point? Tell me. In this question, what should be your starting point? Let me know. This is the question that is given to you. What should be your starting point? Okay, see, all the attributes, they appear on the RHS. So your starting point should be take one attribute. Start from one attribute. Start from single attribute. Yes or no? Start from single attribute. Okay. Which attribute do you see? Which attribute has more potential? What do you think? Which attribute has more potential? Maybe E. Okay. Some student is saying E. So, okay, let's check E. No problem. Okay, let's check E. Anyway, we have to check everything. We have to check everything. But let's start with E. So tell me what is E plus? What E can bring? E can bring E by reflexivity. E can bring ABC. E can bring ABC. What else? These 4 people, what they can bring? These 4 people, they can bring A, B, C, E. What else they can bring? That's it. They cannot bring anything else. Yes or no? That's it. These 4 people, they cannot bring anything else. Agree? So E is not a super key. Yes or no? So I can say this E is definitely not super key. This is not a super key. Okay. Which other attribute? See, A can bring BC. E can bring ABC. So that's it. Yes or no? E is not a super key. Agree with me? E cannot bring F. E cannot bring F. Right? E cannot bring F. Okay. So you can see this is your E is not a super key. What else? So which attribute should I check? Tell me which attribute should I check? Let me know. Okay. So let's check F. No problem. Some students are saying F. Let's check F. Okay. Let me check F. What F can bring? What are the closure of F? F can bring F. F can bring CD. F can bring CD. These 3 people, what they can bring? See, these 3 people, F, CD, what they can bring? CD can bring BEF. F you already have. Okay, so CD can bring BE. Now we already know E can bring A. Yes or no? E can bring ABC. So E can bring ABC. Did we get everything? Did we get everything? A, B, C, D, E, F. Yes or no? We got everything. So we got everything. We got the entire relation R. We got the entire relation R. Now what? Now what? We got entire relation R. Now what? Now I can say that this F is a candidate key because this is minimal. Yes or no? So I can say F is a super key. F is super key and F is minimal. So finally what I can say? F is super key and F is minimal. So what I can say? I can say that F is a candidate key. Okay, F is a candidate key. Now something interesting. See, F is a candidate key. Now, is there any attribute which can determine F? Is there any single attribute which can determine F? Is there any single attribute? I am asking single attribute. Is there any single attribute which can determine F? Okay, no. Now we have to check the remaining single attributes. Okay, we have to check the remaining single attributes. Okay, we cannot go to double attributes. Don't go to double attributes. First, you check all the single attributes. So E we have checked, F we have checked. Okay, will A work? Let me know. Will A work? A will give you what? A will give you ABC. A will give you ABC. That's it. So A will not work. Will B work? Will B work? No, B will also not work. B will also not work. See, notice one thing. A cannot work, because if A can work, then E also would have worked. Okay, just use the logic. Just use the logic. Just think about it. Tell me, A cannot work, right? Because if A is a candidate key, if A is candidate key, if A can bring everyone, then E also will be candidate key. Yes or no? But we have already checked that E is not candidate key. Do you agree? Yes or no? Is this clear? See what I'm saying. Did you understand this? Did you understand this? That look at this E. Look at this E. E is saying that you got A, B, C, E. Okay. Now notice, this E is not candidate key. This E is not candidate key. Okay. So automatically what I can say? Tell me automatically what I can say. If E is not candidate key, so automatically what I can say? I can say that A is also not candidate key. Because if A is candidate key, then E also will become candidate key. Because E can determine A. Yes or no? If A can determine everyone, then E also can determine everyone. Similarly, B cannot be candidate key. Similarly, C cannot be candidate key. Okay, yes or no? So A, B, C, these you don't have to check. Did you understand? Please tell me. Let me know. Did you understand? You don't have to check A, B, C. These three people you don't have to check. Okay. So can I give you a note here? Can I give you a note here? See, assume. Okay, let's assume that X plus, you find X plus, and in this X plus, let's assume that you have these attributes. These attributes you have, let's assume something like A, B, C, something like this. Okay, let's assume you have these attributes, A, B, C, D. Okay, here remember, these are single attributes. This is a attribute. Okay, this is not set of attribute, this is a attribute. Okay, this is a attribute. And remember, these are attribute. This is attribute, this is attribute, this is attribute. And this is set of attribute. This is set of attribute. Okay, this is set of attributes. So please understand, these are an individual attribute. An individual attribute. Okay, now you tell me, if X is not candidate key, just tell me this point. If X is not candidate key, if X cannot determine everyone, if X cannot determine everyone, very simple word I am asking, if X is not super key or candidate key, whatever. So tell me, if X is not candidate key, then can I say A is also not candidate key? Then tell me, if X is not candidate key, remember, very simple point I'm asking, if X is not candidate key, if X is not candidate key, then any combination of ABCD cannot be candidate key, right? Yes or no? Then any combination of ABCD, then any combination of ABCD, then any combination of ABCD, that cannot be a candidate key. Is this simple? Tell me. Then any combination of ABCD cannot be a candidate key. Cannot be a candidate key. Understood? Yes or no? See, this X is basically set of attributes. This X is not an attribute. Maybe this X is AB. Maybe this X is AB. Maybe this X is BC. This X is set of attribute. This X is not attribute. Please notice. This X is set of attributes. This is not attribute. X is not attribute. X is not attribute. X is set of attribute. X can be attribute. Maybe X is A. Maybe X is A. Is this clear? Maybe X is A. Maybe X is AB. Maybe X is ABC. Okay. These ABCD, these are individual attributes. All of them are individual attributes. So please tell me, did you understand the logic? Simple logic I am asking. Did you understand this logic? Did you understand? See, if you know X is not candidate key, means X cannot determine everyone. X cannot determine everyone. So there is obvious thing that these people, they cannot create candidate key. These people, they cannot determine everyone. Yes or no? Is this clear? Please tell me. Okay, is this clear? So here, in simple words, I can simply say, okay, I can say like this. I can say that if X is not super key, if X is not super key, actually I should say super key. If X is not super key, okay, actually I should say super key. Okay, I should say super key. Here in this, I should say super key, because candidate key is minimal. There is a minimal condition also. Okay, so I should say super key. Okay, let me correct myself. I should say super key, because candidate key is minimal. Okay, there is a minimal criteria. There is a criteria for minimal. Okay, so I should say super key. So let me correct myself. This should be super key. Okay, now this statement, did you understand that? If X is not super key, what it means? First, you tell me what this means. X is not super key. What this means? X is not super key. What this means? X is not super key. This means X cannot determine everyone. Yes or no? X is not super key. That means X cannot determine everyone. So tell me, if X cannot determine everyone, then these people also cannot determine everyone. Because if these people can determine everyone, then X can determine everyone. Yes or no? Is this clear? Please tell me. If these people can determine everyone, then X also can determine everyone. Okay. So if X is already, if you know that X is not super key, then any combination of these people cannot be a super key. Cannot be a super key. Okay. Anyway, this is just a small point. This is just a small logic to save your time. Okay. This is just a small logic so that you can save some time. Okay. Anyway, so let's come to this question. So in the individual attribute, what you don't have to check? In the individual attribute, what you don't have to check, tell me. In the individual attributes. So, okay, remember, E is not a super key. So you don't have to check A, B, C. Yes or no? E is not a super key. So no need to check. No need to check. So no need to check combination of ABC. Combinations of ABC. Combinations of ABC. Is this clear? Okay. Anyway, this is just a small point. If you understood, very good. If you did not understand, don't worry. If you did not understand, then don't worry about it. Okay. Do not worry about it. We can still solve. So anyway, what we have done, see what we have done so far. Did we check all the single attributes? Tell me. Did we check all the single attributes? So far, remember, F is a candidate key. We got F is a candidate key. We know that E is not a candidate key. A is not a candidate key. B is not a candidate key. C is not a candidate key. What else? What else? What is remaining? What is remaining? So we have, so far we have seen A, B, C, E. These are not candidate key. F is, and what about D? Please tell me, what about D? You can see D is also not candidate key. Okay, you can check. D can determine only D. So two people are done. Okay, two people are done. Now single people are done. Now tell me two people. Okay, now I will take two attributes. Now I will take two attributes. Tell me, when I take two attributes, can I consider F? Now I will consider two attributes. I am going to consider two attributes. Okay, I will consider two attribute combinations. So tell me, if I consider two attributes combination, then can I consider F? Can I consider F? No, there is no need to consider F. Okay, you don't have to consider F. Okay, you cannot, because remember, F is already candidate key. F is already a candidate key. So using F, you cannot create a bigger candidate key. F is already a candidate key. So using F, you cannot create a bigger candidate key. Okay, so tell me, is there anyone who can determine F? Is there any two attribute combination which can determine F? Is there any two attribute combination which can determine F? Yes, CD. Okay, notice. CD can determine F, and this F can determine everyone. Okay, and this is minimal also. Yes or no? So this is super key and minimal. This is a super key and this is minimal. And this is minimal. So what I can say? And this is minimal. So I can say this is a candidate key. Okay, clear? So CD is a candidate key. Okay. Is there anyone else who can determine F? Is there anyone else who can determine F? Tell me. Anyone else who can determine F? No. Okay. So CD is a candidate key. Okay. What else? We have to check many combinations. What about AB combinations? But tell me one thing. Something will help you. Something will help you. What is that? Something will help you that you don't have to consider combination of these four people. Yes or no? See, this will help you. See, you might be thinking two attribute combination. We have to check AB. We have to check AC. We have to check AD. Yes or no? Many we have to check. Do you agree with me? Are you thinking that we have to check many? Okay. But you don't have to do that. Why? Tell me why. Because I told you that E is not a super key. Okay. So there is no need to check combination of A, B, C, E. Understood? So this logic can help you, right? See, this logic can help you that E plus, that will give you A, B, C, E. A, B, C, E. Okay. Now you can notice that E, this is not a super key. This is not a super key. Okay, what that means? That means E cannot determine R. E cannot determine R. Okay, yes or no? E cannot determine R. So what I can say? So any combination of A, B, C, E cannot determine R. So any combination of A, B, C, E cannot determine R. Cannot determine R. Determine R. Okay. So any combination of these four people cannot determine R. Okay, yes or no? So you don't have to check their 2-2 combination. Their 2-2 combination, you don't have to check their 2-2 combination. So what else? What next 2-2 combination you will check? Tell me. What next 2-2 combination you will check? 2 attribute combo. 2 attribute combo. Which next combination you will check? CD you have checked. Okay, you don't have to check among these people. Okay, so next 2-2 combination will be like, yeah, that will be ED. Okay, yes or no? You have to check ED. For example, you have to check ED, you have to check AD, you have to check BD, and you have to check CD. Tell me, which of them will give me R? You have to check. These people you have to check. Yes or no? You have to check ED. Will this give me R? Let me know. This ED, will it give me R? See, E will give me A, B, C, E. Yes. Okay, yes or no? Because ED, notice what ED will do. Notice what ED can do. See, ED can give me CD, right? Yes or no? ED can give me CD. Agree with me? ED can give me CD. ED can give me CD. That's it. That's it. This is your candidate key already. Okay, so this is also correct. Yes or no? Is this clear? Please tell me. So this also you got. What about AD? What about AD? Please tell me. What about AD? See, AD can give you CD. See, AD can give you CD. AD can give you CD. AD can give you CD. Okay, and this is already a candidate key. AD can give you CD. So that's it. So that's it. So what you got? Tell me. So what you got? Let me know. This is also a candidate key. Okay, what about BD? What about BD? Tell me. What about BD? BD Zalaile. Tell me. So here, this BD, what it will give? So here you can notice BD can give only BD. Okay. BD can only give BD or cancer. Okay. So anyway, so BD can give you cancer. BD will not give you anything else. So anyway, tell me what about CD? Okay, CD we have already checked. CD we have already checked. So there is nothing to check here. CD we have already checked. This is your candidate key. Okay. So simple, right? Is this clear? Please tell me. So finally, what is your answer? I can say in the 2 attribute combination, what you got so far? Okay, remember, we are not over. So far, what are the candidate keys? We are not over. This is not over. The game will go on. Okay, so far what we got? Just tell me. So far F we got, CD we got, AD we got, ED we got. Yes or no? So far these people we got. Is this clear? So far these people we got. Now we have to check 3 combinations, 3 attribute combinations. Is this clear? So now check 3 attribute combinations. Okay, in the 3 attribute combination, what we have to check? Tell me. Now we have to check 3 attribute combination. So you don't have to consider F. There is no need to consider F. Remember, F is already a candidate key. You know that AD is candidate key, CD is candidate key, and ED is candidate key. These people are already candidate key. Okay, all these people. So tell me, which 3 attribute combination you will check? You don't have to consider this F. Now from these, you have to create the 3 attribute combination. The 3 attribute combination. For example, and remember one more thing, that you don't have to consider this ABC, yes or no? Okay, these ABC, these people, you don't have to consider. ABC means, so tell me what is left. Okay, this means don't create combinations in these people, in these 4 people. You have to consider D. You have to take D into the action. Yes or no? You have to take D into the action. Correct? Agree with me? You have to take D into the action. These 4 people cannot do ABC, yes or no? See, notice. These 4 people, if you find, they are not even a super key. If you notice, these 4 people, A, B, C, E, they cannot even give you anything else. This is not even a super key. Correct? These 4 people, this is not even a super key. Not even a super key. Okay, so because this is not even a super key, so you don't have to create combinations from these 4 people. So you cannot take F, so you must take D. So you must take D and 2 people together. Yes or no? You cannot take F. You cannot take F. You must take D. You must take D. Okay, so 2 people together. But whatever 2 people you take, can I say that will be superset of this? If you take 2 people, see, if you take 2 people, but remember, you cannot take superset of AD, CD, ED. Okay, so whatever you do, that will be what? That will be what? That will be superset of candidate key. Yes or no? That will be superset of candidate key. Okay, so anyway, that's it. So now you can stop and you can say that these are your final answer. Okay, now you can stop and you can say the final answer you got. So what is the final answer? What is the final answer? So final answer will be your F is a candidate key, AD, CD, ED. So these are 4 candidate keys. Okay, there are 4 candidate keys. Is this clear? Shall I move on? Please tell me. Let me know, did you understand? Please tell me. Okay. So this thing can help you. Okay, this note I am giving you to save time. Okay, maybe it can save you some time, right? Do you agree? This thing can save you some time. That what I'm saying that if you know that X plus, okay, let's assume you find X plus, and in X plus, let's assume you have A, B, C, D. Let's assume, okay, let's assume in X plus you have this, where these are individual attributes. Okay, these are individual attributes. These are attributes. Individual attributes. Okay, all of them, these are individual attribute. This is individual attribute. This is attribute. Okay, this is attribute, and this is also attribute. So all of them, these are individual attribute. Okay, and what is this X? What is this X? This X is set of attribute. This X is set of attributes. This can be A. For example, this X can be A. This X can be B. This X can be AB. This X can be ABCD, whatever. Okay. Now, what is the note? The note is this. If X is not super key, if you know that X is not super key, if X is not super key, then any combination of these people cannot be super key, right? Yes or no? Then any combination of these people cannot be super key. Is this clear? Then any combination of these people cannot be super key. Please tell me, did you understand? Then any combination of these people, any combination of these people cannot be super key. Cannot be super key. Understood? Let me know. This can save you some time. Okay, like in the previous question, this can save you some time, right? You don't have to check a lot of combinations. For example, when you create three attribute combination, when you are creating 3 attribute combination, you don't have to create all the combinations. You don't have to check all the combinations. You can play smart. Okay, some smart game you can play. Yes or no? So this will save you some time. This can save you some time in some questions, this logic. And this is a very simple logic, because if this is not a super key, means this cannot determine everyone. X cannot determine everyone. If X cannot determine everyone, then these people also cannot determine everyone, because if these people can determine everyone, then what will happen? If these people can determine everyone, then X also can determine everyone. Yes or no? Yes or no? So very simple. This is a simple logic, and this logic can save you some time. Okay. So let's move on now. Tell me the answer for this question. Consider the relation ABCDE. Suppose the functional dependencies are given to you. Which of the following attributes is a key? When I say key, that means candidate key. I told you that this is a candidate key. When I say key means candidate key. Okay, yes or no? Key means candidate key. When we say key, that means candidate key. So now tell me, is there any attribute which does not appear on the RHS? Is there any attribute which does not appear on the RHS? Tell me. You can see AE. AE does not appear. So notice that So you can note that AE does not appear on RHS. AE not appear on the RHS, correct? This A comma E not on RHS. Not on RHS of any FD. Of any FD, right? Yes or no? They are not on RHS of any FD. So now what? So they must be part of every FD, every candidate key. So AE must be part of every candidate key. Must be part of every candidate key. They must be part of every candidate key. Remember, they must be part of every candidate key. Are they enough? Okay, so let's start with them, because these two people, they must be part of every candidate key, whatever candidate key you take. Okay, so they must be part of every candidate key. Are they enough? Are they enough? Okay, tell me, are they enough? So you can see AE, what they can determine? They can determine AE. AE can determine D also. Okay, yes or no? AE can determine D also. What else? What else? D can determine B also. What else? What else? AB. AB can determine C also. Yes or no? AB can determine C also. So simple. So I can say answer will be AE. Remember one thing. AE must be part of every candidate key and AE is enough. So can I say no other candidate key possible? Yes or no? Yes or no? Observe. This point you observe that AE must be part of every candidate key. This must be part of every candidate key. This must be part of every candidate key. And if A is a candidate key, if A, this itself is candidate key, if this itself is enough, if this itself is candidate key, then no other candidate key can be possible. Do you agree? Yes or no? If this itself is candidate key, then no other candidate key is possible. Then no other candidate key is ever possible. Is it possible? No other candidate key is possible. Okay, because this must be part of every candidate key. Whatever candidate key you take, this must be part of every candidate key, and this itself is enough. So no other candidate key is possible. Simple. Okay, so for this question, the answer will be AE. This will be your answer. Tell me the answer for this question. Find all the keys. Find all the keys. Keys means candidate key. Yes or no? Key means candidate key. Okay, by default, I told you this key, this means candidate key. Okay, whenever you see this word key, this means candidate key. This relation is given to you A, B, C, D, E, F, G with functional dependencies. These functional dependencies are given to you. Now, demonstrate your knowledge by identifying which of the following is a key. First, you tell me, is there any attribute which does not appear on the RHS of any FD? Is there any attribute which does not appear on the RHS of any FD? Any FD. You can see A appears. A is appearing, C is appearing. Okay. A, C, E. These people are appearing. A, C, E, G. A, C, E, G. A, C, E, G. Only they are appearing. Yes or no? A, C, E, G. A, C, E, G. A, C, E, G. Notice. A, C, E, G. Only these people are appearing on the RHS. So BDF do not appear, right? So can I say BDF must be part of every candidate key? Can I say that this BDF must be part of every candidate key? Part of every candidate key. Okay. So are they enough? This BDF itself is enough. Can I say BDF itself is enough? Let's check BDF closer. What it can bring? This BDF. This can bring BDF. What else it can bring? What else it can bring? BDF. Cannot bring anything else. So this is not enough. Okay, this is not enough. Yes or no? So BDF cannot bring anything else. Only BDF. So what we will do? We will add one more attribute. Yes or no? Now we will check, can we add one more attribute? Okay, with this BDF, let's add one more attribute. Go in a systematic way. Go in a systematic way. Tell me, what about ABDF? What about ABDF? Can they bring everything? They can bring AB, DF. What else? AB can bring C. AB can bring C also. Okay, AB can bring C. What else? CD can bring E. CD can bring E. CD can bring E. Yes or no? Okay, did we get everything? A, B, C, D, E, F. Okay, can you bring G also? Yes, EF can bring G. EF, these two people can bring G. So we got everything, right? Yes or no? So we got everything, correct? Because these two people can bring G. They can bring G also. So we got everything. So what I can say? So what I can say? So what I can say? These are super key and minimal, right? Okay. So remember, these are super key and minimal. So these are candidate key. So these are candidate key. Yes or no? So these are super key and they are minimal. And because they are minimal, so this is candidate key. So ABDF. What else? What else? Let me know. So ABDF is there. What else? With this BDF, can you add something more? This BDF, A we have added. Now let me add C. What about if I add C? Will I get everything? Please tell me. Will I get everything if I do CBDF? CBDF. What I will get? I will get CBDF. CD will give me E. Yes or no? CD. CD. This CD. This will give me E. So I got E also. BC will give me A. Yes or no? BC will give me A. Now you can stop. See what I can see. Notice. Okay, now you can stop because BDF A, this itself can give you everything. Yes or no? ABDF. This ABDF, this itself can give you everything. So now it will give you everything, right? Okay, now it will give you everything. So you got everything, right? A, B, C, D, E, F, G, everything you got. So that's it. Okay, so this is your candidate key. What else? With BDF, can I do something else? Yes, I can try E. If I add E, what I'm getting? What I'm getting? Tell me. If I add E. So what I will get? I will get EBDF. Now you can see that EBDF I got. Okay, this D can give me C. This DE. This D can give me C. Okay, now notice. This BC can give me what? This BC can give me A. Now, this BDF A. This BDF A can give me everything, right? Yes or no? This BDF A can give me everything. Can give me everything, right? Correct? Is this clear? Please tell me. So again, you got everything. Finally, just check this also. Just check this also. GBDF. What about this? GBDF. What about this? What this will give you? Tell me what this will give you. This will give you GBDF. What else? So you got GBDF, you got. What else I can get? I cannot use this. I cannot use this. Okay, GF can give me what? GF can give me E. Yes or no? GF can give me E. GF can give me E. Okay, now I can stop. Why? See, now I can stop because this itself can give me everything. EBDF. This EBDF. This itself can give me everything. This can give me everything, right? Okay, now automatically you will get everything. You will get A also. You will get C also. Okay, yes or no? Now automatically you will get everything. A, B, C, D, E, F, G, everything you got. Correct? That's it. So you got R. So this is also candidate key. Okay, so remember, BDF must be part of every candidate key. Now with this, if you add one more attribute, everything is candidate key. Yes or no? With this BDF, if you add one more attribute, this you add, this is also candidate key. With this BDF, if you add this is also candidate key. With this BDF, if you add this is also candidate key. And with this BDF, if you add this is also candidate key. Do you have to check 5 attributes? Do you have to check 5 attributes? Tell me, combination of 5 attributes. Do you have to check combination of 5 attributes? You don't have to check. Yes or no? Because combination of 5 attributes will be superset of this. If you take combination of 5 attributes, that will be superset of this. You can take combination of 5 attributes, that will be superset of this. So you don't have to check combination of 5 attributes. So which of the following is a key? The answer is option A is also the answer. BDEF. BDEF. Correct? Okay, BDEF, that is a correct. Next. This is not correct. BD, this is not correct. This is not correct. Okay, tell me one thing. If this question comes in the GATE exam, then how much time you will take to solve this question? if this question comes in the GATE exam, then how much time you will take to solve this question? If this question comes in the GATE exam, see, notice that BDF must be part of every candidate key, right? Okay, notice. BDF, this BDF must be part of every candidate key. Must be part of every candidate key. See, notice. This must be part of every candidate key. Okay, so tell me, which options are gone? This must be part of every candidate key. This must be part of every candidate key. So which options are gone? Tell me. This BDF must be part of every candidate key. So this option gone, this option gone, this option gone automatically. Now you can just check this. Okay, your answer will be automatically this. Yes or no? 3 options are gone. 3 options are already gone. Okay, only 1 option is remaining. If you have eliminated all the remaining possibilities, then whatever remains must be true. Yes or no? This is a quote actually, I think. Have you heard it? If you have eliminated the impossible, then whatever remains must be true, something like that. Okay, so you can see 3 options are gone. Only 1 option is remaining. So that must be correct. And you can check, yes, this will be correct. You can check, this will be correct. If you want to check, you can check. Okay, if you want to check this, you can check, this will be correct. Okay, this will determine R, and this will be minimal. Okay, and this will be minimal, and this BDF will be minimal. Okay, so that is the reason this is candidate key. So very easily you can do this question. Okay, in the GATE exam, if they ask you this question, you can eliminate the options and you will get your answer. Very simple. But if they ask you how many candidate keys, then what you need to do? If they ask you how many candidate keys, tell me in the same question, if they ask you how many candidate keys, now you have to solve this. Okay, there are 4 candidate keys. Now you need to solve it completely. Complete question you have to solve. Let's solve this question, GATE exam question. This is GATE Computer Science 1999 question. So let's solve it. Relation R is given to you, A, B, C, D, E, F. 6 attributes are there. This is a schema, relation schema. With the following functional dependencies, these functional dependencies are given to you. Which of the following is a key for R? What this key means? Please tell me what this key means. When you see this word key, this means candidate key. This does not mean super key. This does not mean primary key. Remember, key means candidate key. I told you this is given in the Ullmann book, right? Yes or no? Okay, most of the authors, majority of the authors, remember, like Ullmann, Korth, okay, most of the authors, they assume that key means candidate key. That key means candidate key. Okay, most of the authors, they assume that key means candidate key. Okay, so remember, key does not mean super key does not mean primary key means candidate key. So here the question is asking which of the following is a candidate key. So how to solve this question? Tell me. So you can eliminate the options. What you can do, you can eliminate the options. First you check, is there any attribute which does not appear on the RHS? Is there any attribute which does not appear on the RHS? Let's check. Which attribute does not appear on the RHS? Tell me. Which attribute is not appearing on the RHS? You can see A appears, A is appearing, B is appearing, D is appearing, F is appearing. A, B, D, F. These are appearing. So C does not appear, right? So I can say that C, E, they are not on RHS. They are not on RHS of any FD. Correct? They are not on RHS of any FD. So what should happen? So C must be part of every candidate key. So this C must be part, this must be part of every candidate key. Correct? Yes or no? This C must be part of every candidate key. Now you tell me, this C, is it enough? This C itself, is it enough? This C, this itself is enough or not? Let's check what is the closure of CE. That will be CE. What else you can bring? This CE. Remember, C can determine F. This C, this can determine F. So you will get F also. This E can determine A. Yes or no? You can see this E can determine A. So you got A also. What else? So you can see this A can determine B. This A can determine B. So you got B also. What else? What else? we need. Okay, so we got everything, but we did not get C yet. C, D. So we got A, B, C, E, F. A, B, C, E, F. We did not get D. Okay, can we get D? Yes, EC can bring D. EC can bring D, right? Notice this. Look at this. EC. This EC can bring D. This can bring D. So you got the entire relation R. Closure of EC, that is your entire relation R. So remember, this must be part of every candidate key. This CE must be part of every candidate key, and this itself is enough. Yes or no? CE must be part of every candidate key, and this CE itself is enough. So tell me, no other candidate key possible? Yes or no? Correct. So you can see C plus that is your entire relation R. So no other candidate key possible. So no other candidate key possible. No other candidate key is possible. Okay. There is no other candidate key possible. So answer will be what? The answer will be option B. How can you eliminate the options? You don't have to solve the question. You can eliminate the options. How can you eliminate the options? You can notice CE must be part of every candidate key. Yes or no? So CE must be part of every candidate key. So automatically these options are gone. These options are gone. Only this will be the remaining options. So this will be correct. Because CE must be part of every candidate key. This CE must belong to every candidate key. Okay, this must belong to every candidate key. So that is the reason I can say option A, C, D. These are gone. So automatically answer will be option B. Let's move on now. Tell me the answer for this question. This is GATE 2005 question. Consider relation schema R, A, B, C, D, E, H on which the following functional dependencies are given. Set of functional dependencies given to you. What are the candidate keys of R? So first you tell me, is there any attribute which does not appear on the RHS? Is there any attribute which does not appear on the RHS? Tell me. So you can see this A, C, D, A, C, D, B, they are appearing on the RHS. A, C, D, B, they are appearing on the RHS. E, H do not appear on the RHS. Yes or no? So you can notice that E, H, these two attributes, these are not on RHS. These are not on RHS of any FD. Of any FD. They are not on RHS of any FD. So what should happen? So they must belong to every candidate key. So this EH must be part of. This must be part of every candidate key. Correct? They must be part of every candidate key, right? Okay, very simple. So now tell me, are they enough? This EH, are they enough? First you check, because they must be part of every candidate key. Whatever candidate key you take, this EH must be part of every candidate key. Okay, so first you tell me, this EH, is it enough? Let's check what are the closure of EH. So EH can bring what? EH can bring EH. Anything else? No. Okay, yes, E can bring C also. E can bring C also. So you got EHC. What else? So this is the closure of EH. Correct? So I can say this EH is not a super key, right? This EH, this is not a super key because EH cannot determine everything. EH cannot determine everything. So what we need to do? Remember, EH must be part of every candidate key. So now what you do? Now you add one more attribute. With this EH, you add one attribute and you check. Okay, let's add one attribute and check. So with this EH, let me add A and let me check. Let me check what is the closure. If I give this power, this EH, remember EH can determine EHC. Okay, so what you got? This EH can determine EHC. So these are these four attributes you got. What these four attributes can bring? These four attributes, what they can determine? These four. You can see A can determine B. Yes or no? This A, this can determine B. So you got B also. What else? Tell me. You can see BC can determine D. Correct? This BC, you can see this will determine D. So you got D also. Okay, so did we got all the attributes? Yes, we got all the attributes, right? So we got the entire relation R. Okay, so what this means? This is a super key. This means this is a super key. And because this is minimal, remember this AEH, this is super key. And since it is minimal, since this AEH is minimal, So I can say this is candidate key. Yes or no? Because this is minimal. So what I can say? So I can say this is a candidate key. ECH. This is a candidate key. Okay. So you got your one candidate key. You got this AEH. Okay. So you got AEH. Now tell me what else? Let me know. What else? First of all, you tell me one thing. Some options you can eliminate, right? Some options you can eliminate because this EH must be part of every candidate key. EH. You can see this EH must be part of every candidate key. So some options you can eliminate. What are the options you can eliminate? EH must be part of every candidate key. So some options are gone. Which options are gone? This option is gone. This option is gone. These options are definitely gone because EH must be part of every candidate key. Okay, this is already very simple that this EH, this must be part of every candidate key. This must be part of every candidate key. Every candidate key. Okay, so this must be part of every candidate key, this EH. So automatically which options are gone? So actually this option is also gone, right? This option is also gone. Option C is also gone. So answer will be option D. Only option D is remaining. Yes or no? Only option D remaining because EH must be part of every candidate key. So option C is also gone. So only option D is remaining. Actually, you don't have to solve this question. The answer will be option D. Yes or no? You don't have to solve the question. You can easily see that answer will be option D. But in the question, if they ask you how many candidate keys are there, then what you need to do? In the question, if I ask how many candidate keys are there, in the GATE exam, you don't have to solve this question. You can directly say answer is option D because you can eliminate ABC. These options you can eliminate. But in the GATE exam, if they ask you how many candidate keys are there, then you have to compute. Yes or no? Then you have to calculate. Now you have to solve the complete question. So tell me, we have already found that this AEH. Okay, so this AEH, this we found candidate key. What else? What else we need to check? Okay, let me check this BEH. What the closure of BEH? Tell me, the closure of BEH, that will be BEH, and this E can bring C, this E can bring C. What else? Tell me, what else? Let me know. So you can see BC can bring D, this BC, it can bring D. So you got D also. Now D can bring E, D can bring A, this D can bring A. Yes or no? So you got everything. You got A, B, C, D, E, H. So you got everything. Okay, you got everything. So this is super key. Okay, so what I can say? So I can say this is super key. Correct? This is super key. And because this is minimal, and since this is minimal, this BEH is minimal super key. Because this is minimal super key. So what I can say? So what I can say? So this is candidate key. So this BEH, this is a candidate key. Yes or no? So you got this another candidate key. What else? Tell me. What else we have to check? So AEH we got. This is a candidate key. BEH we got. This is a candidate key. Now we have to check CEH. Okay, let's check CEH. What about this? Is this a candidate key? This is CEH. Tell me. Will it bring everything? See, this can bring CEH only. Nothing else, right? Okay, you can get nothing else. Nothing else you can get. So definitely this is not even a super key. Yes or no? So this is not a super key. Not even a super key. This is not even a super key. Okay, now you tell me. So now you have to check DEH. This DEH you have to check. What is the closure of DEH? DH will give you what? This will give you DEH. Remember, D will give you A. D will give you A. Okay, this D can give you A. Now you can stop, right? Now this itself can give you everything. Yes or no? This AEH, this itself can give you everything. This itself can give you everything. This AEH, this will give you everything. Okay, this will give you B, this will give you C, everything. So you can stop. Okay, so finally, this is your answer. Now tell me, do you have to check 4 attributes? Combination of 4 attributes, will you check? Will you check combination of 4 attributes? Tell me. Let me know. See, so far we got these candidate keys. AEH, this is a candidate key. BEH, this is a candidate key. DEH, this is a candidate key. Now you tell me, do you have to check combination of 4 attributes? 4 attributes combination. Let me check. Okay. Will you check 4 attribute combinations? 4 attributes combo. Okay, 4 attributes. But 2 of them are already fixed. Yes or no? 2 of them are already fixed. What are those? 4 attribute combo you are checking, but 2 are already fixed. EH must be part of every candidate key. EH, these are fixed. Now you tell me. If you do this, what 2 attributes you will take? Which 2 attributes you will take? See, you must make sure that you don't get superset of these. Okay. See, whatever 2 attributes you take, this will become superset of candidate key. This will become superset of candidate key. Yes or no? Is this clear? Whatever 2 attributes you take, whatever 2 attributes you take, this will become superset of candidate key. Proper superset of candidate key. Okay. If you take 2 attributes, then this will become proper superset of candidate key. So what I can say? I can say, so this is not a candidate key. Yes or no? This is not a candidate key. Is this clear? Please tell me. Okay. So you don't have to check 4 attribute combinations. So your answer will be what? How many candidate keys are there? If they ask you how many candidate keys, the answer will be 3. Okay. This will be your answer. So let's move on now. Let's solve this question. Can I give you this question as a homework? This GATE exam question? Maybe, okay, we can solve this question and I will give you some other questions as a homework. Okay, because this is GATE exam question, let's solve it. Then I can give you this question as a homework. Okay. So let's solve it. So this is GATE Computer Science 2014 question. Let's solve it. Consider relation schema R. These are the attributes. So many attributes are given to you. The set of functional dependencies. These are the functional dependencies that are given to you. The question is asking, what is a key? What key means? Tell me. What is the key? Key means candidate key. Okay, key means candidate key. Most of the authors, remember I told you, most of the authors like Ullman, NPTEL. Okay, so most of the authors, they assume that by default key means candidate key. Okay, by default, this word key, this means candidate key. Okay, so remember the question is asking for candidate key. Now, these functional dependencies are given to you. Okay, these functional dependencies. Do you remember I told you what this functional dependency actually means? What is the another notation for this? There is another notation, simple notation. What is the simple notation for this? Please tell me. What is the simple notation for this FD? The simple notation is L determining N. Yes or no? This is the simple notation. For example, what is the simple notation for this? What is the simple notation for this FD? For this FD, what is the simple notation? Tell me. For this FD, what is the simple notation? The simple notation is EF determining G. This is the simple notation, right? Yes or no? Is this clear? We have already seen this. Okay, for example, look at this. Look at this functional dependency. For this functional dependency, what is the simple notation? This is your EH determining KL. Okay, very simple, right? Yes or no? So this is the idea. Now let's solve this question. So functional dependencies are given to you. Is there any attribute which does not appear on RHS? See, these many attributes are given to you. EF, GH, IJ, KL, MN. Now tell me, is there any attribute which does not appear on RHS? So you can see this N is appearing on RHS. This is appearing. Okay, this appears on RHS. This appears. M appears on RHS. This appears. Next, KL appears on RHS. KL, they appear on RHS. Next, IJ appear on RHS. IJ. Next, G appears on RHS. Okay, so you can see that EFH, they do not appear on RHS, right? So you can notice this EFH, these attributes, they are not on RHS. They are not on RHS of any functional dependency. Yes, correct. These attributes, EFH, they are not on RHS of any functional dependency. So who can determine them? They are not on RHS of any functional dependency. So who can determine them? Only they can determine themselves. Yes or no? Okay, these people, these three people, they are not on RHS of any functional dependency. So only these people can determine themselves. EFH, they can determine themselves. Only they can determine themselves. Okay. So I can say that they must be part of every candidate key. This EFH, okay, they must be part of every candidate key. They must be part of every candidate key. They must be part of every candidate key. Now, can you eliminate the options? Remember, they must be part of every candidate key. Whatever candidate key you create, they must be part of every candidate key. Now, can you eliminate the options? So now you can easily eliminate the options. So I can say this is not correct. This is not correct. Okay, now two options are remaining. Yes or no? Two options are still remaining. Okay, option A, option D are gone because EFH must be part of every candidate key. Now still two options are remaining. So let me check what they can bring. Are they enough? EFH, are they enough? Tell me. Are they enough? Let me know. So what they can determine? EFH, they can determine E, they can determine F, they can determine H. What else? EFH. EF can give you G also. Yes or no? Notice EF can give you G also. This EF, they can give you G also. What else? What else? Tell me. EF can give you G also. F can give you IJ. F can give you IJ. Look at F. F can give you IJ. Okay. Now these people, what they can give you? EF, GH, IJ. So you can see EH can give you KL. Okay. Yes or no? EH. Look at this EH. This EH. This can give you KL. This can give you KL. What else? Now you got KL. Remember, K can give you M. This K can give you M. So you got M also. Remember, this L can give you N. This L can give you what? This L can give you. This L can give you N. So you got N also. Did we get everything? Please tell me. Did we get everything? Let me know. Just look at this and tell me. Yes, we got everything. We got everything, right? So you can see that we got everything. Okay, this is your equal to R. We got everything. I can say EFH. This can determine all the attributes. This can determine entire relation R. So that is the reason. What I can say. So this itself is enough. This must be part of every candidate key. This EFH. This must be part of every candidate key. And this itself is enough. So this is the candidate key. And this option C, this is not a candidate key. This is a super key. Yes or no? Okay, option C, that is a super key. So remember this option C, if you look at option C, that is a super key. That is a super key, not a key. Not a key. Remember, key means candidate key. I told you, when you see this word key, this means candidate key. Okay, by default, this word key, this means candidate key. Okay, so whenever you see this word key, this means candidate key. So here, the answer will be option B. Answer will not be option C because option C, that is not candidate key. Okay, that is super key, but that is not candidate key. So your answer will be option B. Did you understand? Please tell me. Did you understand this question? Let me know. So can I give you this question as a homework? You have to find candidate keys for this, and for this. Okay, three relations are given to you. For these relations, you have to find the candidate keys. So discuss these questions in the group. Okay, in the Go Classes private Telegram group, you can discuss all these questions. Okay, make sure that you are comfortable with finding candidate keys because this is important. In the GATE exam, many questions are there. Now let's move on. Let's solve this question. Tell me the answer for this question. This is GATE Computer Science 2002 question. From the following instance, this instance is given to you of relation schema R ABC. We can conclude that which functional dependencies are there. We can conclude which functional dependencies are present. First, you tell me, the question is asking which functional dependencies are present. You tell me, is it asking that within this instance, which functional dependencies are present? Tell me, the question, is it asking which functional dependencies are present in this instance, No, this is not asking. See, please understand the difference between this question and the difference between this question. This is your GATE 2000 question. This is GATE Computer Science 2000 question. In this question also instance is given. This instance is given. But the question is asking which functional dependencies are satisfied by the instance. Okay, which functional dependencies are satisfied by the instance. Is this clear? In this question, you can see in this GATE 2000, in this question, the question is asking by the instance. This instance will satisfy what? Okay, is this clear? This instance will satisfy which FD? Okay, so the question is asking only for instance. Only for instance. The question is asking only for instance. Means this instance will satisfy which FD? Okay, now you come back to this question. Now you come back to this GATE 2002 question. Now, can you notice in this question, instance is given to you. See, instance is given to you, but the question is not asking for this instance what will happen. Yes or no? See, this instance is given to you, but from this instance, you can eliminate some functional dependencies. I told you that if some instance is given to you, if I give you some instance, then some functional dependencies you can eliminate, but you can never confirm that some functional dependency holds. Yes or no? Do you agree with me? I told you that if I give you some instance, okay. Now you can eliminate some functional dependencies from the instance. If I give you this instance, then some functional dependencies you can eliminate, but you can never say that some functional dependency holds. Is this clear? Because functional dependencies, these are defined on what? On the instance or on the schema? Tell me. Functional dependency, they are defined on the instance or they are defined on the schema? They are defined on the schema. You already know. Functional dependencies or any integrity constant, whatever integrity constant you take. Yes or no? Functional dependencies or any integrity constant, they are defined over what? They are defined over schema. They are defined over schema, not over instance. Not over instance. Is this clear? Please tell me. Okay, not over instance. So remember, functional dependencies, these are defined over schema. Did you understand the difference between this question and this question? Please tell me. See, in this question, I am asking which functional dependencies are satisfied by the instance. Means by this instance, which functional dependencies are satisfied. Okay, but now come back to this question. In this question, instance is given to you, but I am not asking you by this instance which functional dependency will be satisfied. Did you understand? Please tell me. Don't keep any confusion. Okay, in this question, you can notice we are not asking that by this instance what is satisfied. By this instance what will be satisfied, that is we are not asking that. Okay, and I told you that if I give you some instance, then from that instance you can eliminate some functional dependency. You can eliminate, but you can never say that some functional dependency will hold, because functional dependencies, these are defined over schema. They are not defined over instance. Okay, is this clear? So now tell me, from this instance, you can only eliminate. You can never say that a functional dependency holds. Yes or no? So remember, you can never say option A. You can never say option B, because you can never say that some functional dependency will hold. Is this clear? Please tell me. Let me know. So if I give you some instance, then you can find some functional dependency you can find which does not hold on the schema. So from the instance, you can eliminate some functional dependency, but you can never say that some functional dependency will hold. So option A, option B, these are gone. Now tell me, what is option C? B does not determine C. Can I say this from the instance? B does not determine C. Yes, you can notice B does not determine C. In these two rows, B value is same, but C value is different. Yes or no? Look at these two tuples. In these tuples, B value is same, but C value is different. B value is same, C value is different. So I can say B does not determine C. Okay, yes or no? So definitely on the schema also this FD will not hold. Yes or no? On the schema, this FD will not hold. Tell me one thing. When can you say that FD will hold on the schema? Tell me. When can I say that some functional dependency will hold on the schema? On the schema, some functional dependency will hold. When can I say? When every instance will satisfy it. Yes or no? When every legal instance will satisfy that FD. Yes or no? Very simple. So remember, some functional dependency will hold on the schema if every legal instance will satisfy that functional dependency. You can see this instance does not satisfy this functional dependency. This instance does not satisfy this functional dependency. So what I can say? So I can say this functional dependency does not hold on the schema. Okay, this functional dependency does not hold on the schema. So I can say F does not determine C. Yeah, that is correct. That is correct. What about the remaining? What about option D? A does not determine B. Can you say this from the instance? From the instance, can you say that A does not determine B? From this instance, can you say that A does not determine B? No. Okay, from this instance, we cannot say A determines B or not. Yes or no? We cannot say. We cannot say A determines B or A does not determine B. Yes or no? Okay, we cannot say. We cannot say A determines B or A does not determine B. So this is what we cannot say. So this is gone. So answer will be option C. Is this clear? Please tell me. So please understand the difference between this question, this GATE exam, this question and this question. Please understand the difference. In this question, instance is given to you and we are asking which functional dependency will hold by the instance. Okay, which functional dependency are satisfied by this instance. Okay, so this is the difference between these two questions. Understood? So for this question, the answer will be option C. Let's move on now. Let's solve this question. This is GATE 2014 question. Read this question and tell me the answer. Given an instance of student relation, this student relation is given to you, instance is given to you. Okay, for a student relation, this instance, this data is given to you. For student name, student age, this combination, student name, student age, this combination. Okay, for this to be a key, we want this to be a key. Then what should be the value X should not be equal to? What should not be the value of X? Remember, we want this to be a key. Tell me one thing. If this is a key in any table, like for example, if you have this A, B, C, D, let's assume you have this table you have. In this table, if I tell you that AB is a key, then what that means? If I tell you that AB, this is a key, whatever key, candidate key or super key, whatever key you take. Okay. If I tell you that AB, this combination is a key. Okay. Whatever you take, candidate key, super key, but by default key means candidate key. Okay. Remember, I told you that by default, please understand, by default key means candidate key. By default key means candidate key. But in this question, it does not matter. In this question, it does not matter. Yes or no? In this question, even if you take it primary key or you take it super key or you take it candidate key, in this question, it will not matter. Okay. But remember, by default key means candidate key. By default, this word key, this means candidate key. Okay. But in this question, it does not matter. You can assume primary key, you can assume candidate key, you can assume super key. In this question, it does not matter. So you can see if AB is a key, then what will happen? AB is a key, then what will happen? Then no two tuples can have same AB value. Yes or no? Then in any instance, whatever instance you take, then in any instance, okay, whatever instance you take, remember, then in any instance, this AB combination, okay, in any instance, this AB combination cannot repeat. Yes or no? Correct? I can say in any instance, this AB combination cannot repeat. this AB combination cannot repeat. Whatever instance you take, this AB combination cannot repeat. So for every two tuples, this AB combination will be different. Okay, for every two tuples, AB combination will be different because this cannot repeat. So now you tell me, if you want this combination to be a candidate key, if you want this combination to be a key, then you can see that no two rows can have same value for these two attributes. Yes or no? For this combination, no two rows can have same value. Or I can say this cannot repeat. Okay, so finally your answer will be what? You can see here, you can note that Sankar comma 19 is already there. See, Sankar comma 19 is already there. This value is already there. For this combination, Sankar comma 19 is already there. So this Sankar comma 19 cannot appear again. Yes or no? Sankar comma 19 is already there. So this Sankar comma 19 cannot come again. Cannot come again. So this x cannot be 19. Okay, so x should not be equal to 19. The answer will be 19. Okay, everything else is fine. Everything else is fine. This x can be 17, 18. Everything else is fine. Okay, this x can be 0, x can be 1. Everything else is fine. But x cannot be 19. If you want this combination to be a key, so answer will be 19. Let's move on. Can you solve this question? Okay, let me give you this question as a homework. Here you can notice E is a key. Key means candidate key. Okay, key means candidate key. The question is asking, what are the maximum number of super keys? This is a very simple question. Answer will be what? Answer will be 8. Yes or no? Answer will be 8. Okay, let's move on. This question also you can try. Okay, just try this question yourself. In this question, the question is saying that this is GATE 1994 question. An instance of relation scheme has instance, remember, instance has distinct value for A. Then can you conclude that A is candidate key? No. From the instance, we cannot conclude, right? From the instance, we cannot conclude. Yes or no? Very simple. Okay. So this is your question. So that's it. We have seen everything. Please tell me, did you understand? We have seen all the concepts. Finding candidate key from functional dependency. Please tell me, did you understand? Did you understand? Are you comfortable? Whatever question comes, can you find candidate key? If I give you set of functional dependency, can you find candidate key? Can you find candidate key, closure of attributes, super key, all these things? Did you understand? Please tell me. Okay. Thank you, everyone. Tell me, is this table allowed in relational algebra? Is this table valid in a relational algebra? In the relational model, is this table valid? No, this table is not valid. But this table is valid in SQL. Okay, we will see. In SQL, this table is valid. But in the relational model, this table is not valid. Why? Because relational model is theoretical model. Please understand. Relational model, that is a theoretical model. SQL is a practical language. You can do coding in SQL. You cannot do coding in relational algebra. We will study relational algebra. In the relational algebra, you cannot do coding. Relational algebra is theoretical language. Relational model is theoretical concept. SQL is practical language. In the SQL, this table is fine. We will see. But in relational model, this table is invalid. Okay, what comes first? First data will come or schema will come? First data will come or schema will come? First schema will come. Yes or no? So remember, in the relational model, your schema must have primary key. Exactly one primary key must be there in the relational model. So please understand, relational model versus SQL. SQL is different. Relational model is different. Relational model is theoretical concept. SQL is practical concept. In SQL, this is fine. In SQL, this is also fine. If you have null, null, null. In SQL, this is also fine. In SQL, you can repeat. This is also fine. In SQL, this is also fine. Is this clear? So these things are fine in SQL, but these are invalid in relational model. So remember, relational model versus SQL. Don't confuse, don't mix. We will study what is SQL. Okay. Right now, we are learning relational model, and that is a theoretical model. Okay, that is a theoretical model. Theoretical concepts, every concept is theoretical concept. Okay, is this clear? Please tell me. So don't confuse relational model versus SQL. This table is not valid in relational model. In the relational model, you must have exactly one primary key. Okay, no two tuples can be same. These things I already told you. Okay. Okay, thank you everyone. Anyone has any other doubt? Any other doubt? Anyone? Please tell me. Any other doubt? Anyone? Okay, thank you.